So what is DevSecOps? Well, DevSecOps is basically a culture shift. It's a methodology. It's integration and automation throughout the whole life cycle of the application. And most importantly, it's a partnership between the development team, the operations team, and the cybersecurity team. When you have gated cybersecurity, it really hinders the agility, and it's incompatible with traditional DevOps workflows. What is it not? Well, first of all, DevSecOps is not a department. I've worked with companies that they'll have your dev team, then you have your security team, you have an engineering team, and lo and behold, you actually have a DevOps team too. It's like, well, that's a methodology. Why would you have a department dedicated for just a methodology when your whole organization is supposed to adopt this methodology? And it's not a tool, and it's not gated cybersecurity. Integrating cybersecurity into the application lifecycle requires leaders to enable a culture shift within the organization itself. Uh, that way, the whole organization has responsibility and has skin in the game. So where do you start? Well, assuming that you're working with an existing suite of applications, you really have to start with a baseline testing. Um, in this baseline security testing, it really must include authenticated and unauthenticated security testing to get 100% code coverage. It should also include static code analysis, software composition analysis, so you know where you're starting with. You know what you're working with, and then later on, when you're testing, you only have to test the deltas, and we'll talk about that in a minute. Dynamic application security testing is typically involved along with manual application security testing when it comes to baseline testing with doing basically a pen testing. So after you've got your baseline, you have an idea of what you're working with. You can start from there. You know what needs to be remediated, but then as you have more sprints, you want to include threat modeling during your planning phase. Threat modeling, basically you're building a document that's a living document, and you're going back to this time and time again. And as your application grows, functionality and inputs, those functions and inputs get captured, and the team gets to whiteboard and whiteboard the idea of what would happen, how could you exploit these functions. Um, Threat modeling provides a summary of possible attack scenarios, and it outlines the flow of sensitive data and identifies vulnerabilities and offers potential mitigation options. Um, so the first portion is to build a system model. That includes your dev teams, obviously, because they know more about everything that has been put into this application, or they should. Second part is finding the threats. We typically use the STRIDE model, and that stands for spoofing, repudiation, information disclosure, denial of service, and elevation of privileges. Those are the key elements that the security teams are looking to find and answer the questions of. Then after that, you address the threats. What mitigations can we put in place? How do we stop an attacker or monitor uh, for this type of threat? And then next is validation model. Um, and you're really trying to find out, did we address the threats previously found last time? So if we look at an example, this is an example of a tool that we use called OWASP Threat Dragon. And basically it's a web interface, and you build out all the different functions and features, the models, the flows, everything. And then down at the left-hand corner, you see security controls checklist. There's only 3. Usually there's a lot more, obviously, in a real scenario. But here you're looking for, is is this wallet, this is a cryptocurrency model, um, is the wallet uh, encrypted at rest? Are the API keys using read-only access? And do you have proper authentication and authorization validation? So as you go through this threat modeling session with the development team, you find out that there is no authentication. It's not encrypted at rest, but the API keys are truly read-only access. And so you mark all these down, and then they get to go back during their coding sessions and actually make sure that this actually is true and it happens, and you mitigate these issues. So next during the planning phase is you address identity management. Kind of starts with data leakage. You're looking for, continuous threat detection, dark web analysis. Our dark web analysis is essentially really is second to none. We find usernames, passwords, session tokens, um, and that should be done on a continuous basis, constantly looking for new threats that are out there that would allow an attacker to potentially get into an application based on leaked information, leaked secrets. Um, you also want to try to prevent secret sharing and hard-coded secrets in the source code using tools like AWS Secrets or Google Secrets. Um, there's a number of different ways to make sure that you don't have secrets hard-coded in the applications and you're just calling that information when you need it in the live application. The next stage is to manage the identities and to enable least privilege. Really, it's just a need to know basis, right? Not everybody needs to know everything. And you do that with role-based access control within the application. We Okta, you can use uh, the built-in tools in Google, Azure. There's many different flavors of authentication that have a lot of these checks and balances built in. Next, you have password security. Obviously, MFA is not a silver bullet, but it sure beats nothing. Um, but you also need to set it up the right way, right? So there's ways to get past MFA as a pen tester. Um, if I can continuously push the button and tell it, check again, check again, check again, and that user is getting the notification, is this you? Is this you? Is this you? A lot of times they're going to go ahead and just submit, yes, this is me. Stop bugging me. That type of MFA is really, really bad. I think the best way to implement MFA is to use something like a token, a one-time token, one-time passwords, where only that user has the ability to put that information in the application and then get in. Um, Pen tester or threat actors can't get that information unless they actually have that phone, your phone, that token. Um, and then you have password managers, things like Keeper, OnePass, Bitwarden. Those are tools that are essential to allow your users to have because they create passwords that are really secure and then they store them. They actually implement them during live while you're logging in, and users don't have to create passwords. And I mean, I'll even throw LastPass in there. I know that it's kind of got a bad name now, but it sure is better than sticky note or notes on underneath your keyboard, right? So the next portion of the planning phase is code standards, right? And that includes people, processes, and tooling. Fostering a culture of security among all stakeholders, from developers to IT operations and to project managers, is essential. You also have to have a security champions program for your development team. But a lot of times you can pick out those folks that are really interested in security that are on your dev team. Those people are very essential to having a good security champions program. And they can work closely with the application security team and kind of bridge that gap between security and development. And they can help accelerate the adoption of secure coding standards. Next are your processes. You really do have to have a secure software development lifecycle written down and implement the security features that are in the plan. And that should include obviously every stage of the life cycle. It should involve some level of security, whether it's development, testing, deployment, and then even maintenance. Um, Doing this allows organizations to shift from a reactive model to more of a proactive model as they deliver software solutions. Next is tooling. And I know security engineers, they love to kind of push these tools down developers' throats. And that's not really, that causes friction, right? Security teams shouldn't try to force the new tools on the development teams. Um, Once friction is kind of in place between development and security, it slows down the rollout of the new tools and slows down the process. So they really should be developer friendly and team focused tools so everybody gets to play.